Hi, welcome back. Today is kind of the follow-up day to Brain Day. We're going to be looking at the meninges that protect our central nervous system, and we'll be looking at the other major part of the central nervous system, our spinal cord. So let's start with the protection. As you know, our brains are very, very important to maintaining life and controlling everything about what we do, how we think, how we move, and regulates everything about us. So it's really important that it's protected. And so our brain comes encased in a skull, which, as you guys know, those cranial bones are made up of flat bones that are specially designed to be protection. In fact, the way the bones come together in sutures that are kind of jagged, you remember the lines on the skull were jagged, that kind of locks those pieces or those bones together, making them hard to separate. So they make a really good protective case for the brain. But that's not quite good enough, because even with a hard case around it, a good knock to the head and bumping it around could actually cause that brain to slam up against the inside of your skull and cause damage. In fact, that is part of the major debate right now about concussions and how we need to protect athletes from concussions, because they're accumulating brain damage from slamming their brains into their skulls from the inside due to all of that impact. Thankfully, normal movements don't tend to do that to us, because our brains do have additional protection besides the skull. Outside of that, we have 3 layers. They're called meninges. Meninges is the root for the word meningitis, if you've ever heard of that. In fact, before you go to college, you will have to get a meningitis inoculation to prove that you've been vaccinated against it before going to college. Anyway, those meninges come in 3 types. The outer tough one is called the dura mater, and it's like a paper bag. This is the dura mater that came off of the pig brain that we looked at yesterday. And you can see that it's a very thick, tough covering. I can tear it, but it's hard to do. It's like wax paper. So, and you'll notice that would be really, I can't push my finger through it. Maybe if I had a longer fingernail I could, but I cannot push my finger through it. It is a very tough sac that's around the brain. And that dura mater extends down to go along the spinal cord as well. So these meninges protect not only your brain, but also your spinal cord. I wanted to show you too that the sheep brains we looked at yesterday also have the dura mater. And it's you'll see that it forms kind of a nice tight seal around the brain. So it's not a loose bag, it's pretty well fitted to the brain itself. Beneath that layer, we have something called the arachnoid, which is a layer that you can't see here, but it secretes liquid or a fluid. We call that cerebrospinal fluid. That is not the liquid dripping from here. This liquid actually is the preservative these brains have been stored in. But normally this sac would not be cut. There would be the dura mater and the arachnoid mater, and between them would be the fluid, the cerebrospinal fluid. And what that fluid does is act as a shock absorber. So if the brain does shift suddenly, there's a liquid cushion before the brain hits the wall of the skull. Then on the very surface of the brain, if you can look, it's very shiny. That's a thin membrane that covers the outside of the brain. In fact, I can pull on it a little bit with my forceps here so that you can see that there is something there. That is the pia mater, which is the third and most immediate covering to the brain. So we start with the brain. It's covered by a thin membrane called the pia mater. Then we have the arachnoid, which secretes fluid. And then outside of that, we have the dura mater, which is this tough papery covering that provides the very outermost protection for the brain besides the skull. Hi, and now we're going to be talking about the spinal cord, which is the other major component of the central nervous system that transmits the information from the brain or from the body to the brain through the nerves out to the different parts of the body. So I would like to show you this model first. You guys may recognize this from when we were studying the vertebral column, when we did the skeletal unit. And we know that the vertebrae have this hole or channel through them that we call the vertebral foramen. And you may or may not have had to know that. But in the middle of that foramen is where the spinal cord transmits through that hole. So if you look down here, you can see that little bit of yellow between each vertebra. That's because the spinal cord is going down through those vertebrae. Notice though that along the way there are also holes on the side of the vertebrae, and that's where the nerves or the nerve ganglion comes out from the spinal cord to serve the rest of the body. So the spinal cord at your neck is roughly 1 to 2 inches in diameter. By the time it reaches your 12th thoracic vertebra, it is very thin. And that's because as the spinal cord goes down along your back, these nerves keep shooting out the side to service your neck, your shoulders, your chest, your back, your abdomen, and then ultimately your arms and legs. And so these nerves take mass away from the spinal cord and send nervous tissue out to the rest of the body. And then it kind of tapers off after about that. Most spinal cords, although they start at about 1 inch to maybe 2 inches in diameter and then taper, they are usually only about 18 inches long from the base of your skull down to mid-back. Now that varies a little bit with the size of the person, but it doesn't go all the way down your back. A lot of people are under the misconception that your spinal cord goes all the way down to your tailbone, and it does not. Okay, so the last specimen I have for you today is a cow spinal cord. And I want you to see that at the very least, there is a membrane around it. Being named the same as what they were around the brain, this thin membrane right here that I'm kind of manipulating with my forceps represents the pia mater surrounding the spinal cord. We good? We don't have any visible dura mater, but we do have nerve ganglion material and some of the fat that surrounds that. Notice that even though a cow is a very big animal, its spinal cord is not that big. Now this is not the full length. This is only a 2-inch segment. I'm sure the spinal cord extends from the head to about mid-back on a cow, which would be further than it does on us. This is only a roughly 2-inch segment of the spinal cord. Okay guys, so I'm zooming in right here at the cross section of the spinal cord. Hopefully you can see these kind of 2 little dots that you can see in the middle of this spinal cord, because there is a structural difference here that I wanted to point out. This is kind of extra for you, but there are 2 kinds of nervous matter in the brain and the spinal cord. One is called white matter and one is called gray matter in the brain and in the spinal cord. They kind of switch places between the 2. In the brain, the overall structure that you see, most of it is white matter. White matter is myelinated, so there is a lot of ability for the signal to travel very fast from one place to another. Myelination helps with that process. So the most of the brain is myelinated, but then it has a very thin outer covering called the cortex, which is made up of gray matter. And these are the cell bodies of a lot of the neurons, and this allows a lot of time for processing and integration of information. Instead of just shooting signals from one place to another, they are allowed to kind of sit there and kind of integrate a little bit. So that's why it's adaptive to have a brain that has a lot of material for rapid transmission of signals with a very thin layer that allows a little bit slower transmission and a better integration of that information. So a lot of people liken this to an apple, where the main fruit part of the apple is like the main part of the brain, and the skin on the apple is like the gray matter cortex around the cerebrum. That gray matter is usually 1 to 4 millimeters thick. In the spinal cord, however, we're really more interested in having a lot of information travel very, very quickly from the body to the brain and back again. So the bulk of our spinal cord, as you notice, looks very white. And that's because most of that is white material, most of that is white matter. And so that's what makes up the outside of the spinal cord. However, there is a function for the spinal cord to be able to, our reflexes depend on our spinal cord's ability to take in information and initiate some kind of response without going all the way to the brain. Therefore, the very center or core of the spinal cord, which kind of looks like this H structure here, is made up of gray matter. So I have a weird little funny human trick that I wanted to share with you.